Hello friends, welcome in Devrat Knowledge Villa and you are learning CPU scheduling. Today's our topic is round robin CPU scheduling algorithm. Round robin CPU scheduling algorithm is working on preemptive mode. Before today we have discussed two types of modes, preemptive and non-preemptive mode. In case of preemptive mode, we can stop any process in between the execution and we can allocate CPU to any other processes. But into the non-preemptive mode, we can't stop any process in between the execution and we cannot allocate CPU in between to the another process. That thing is known as a non-preemptive mode. So let discuss round robin. It is working on preemptive mode, but before start discussing round robin algorithm, if you are till remain to watch our earlier videos of CPU scheduling of other methods, FCFS, SJF and priority scheduling. So please click on I button which is located on upper right corner and watch first those videos and then again reach to here for the better understanding of round robin algorithm. Criteria will follow time quantum and arrival time for the round robin. In case of round robin, into the data table you have given the time quantum look like, for example, whenever you are driving your vehicle and you will reach at a signal, so one by one for the specific time signal is allowing to clear the traffic, and for the remaining time public have to wait into the queue. So one lane is traveling and remaining 3 lanes are waiting into the queue. So same like here, one process will execute for specific time quantum and remaining processes will wait into the queue. Get it? So we will find average turnaround time and average waiting time into the data table. Here given parameters is number of 6 processes P1, P2, P3, P4, P5 and P6, and arrival time for all 6 processes as well as burst time for all 6 processing. One new thing is given, that is time quantum. So we will follow this parameter time quantum in our entire calculation, as well as criteria another followed, that is arrival time. It means whatever the process is arrived first, it will be served first. Get it? Look like FCFS. Let's start calculating turnaround time and waiting time. So first we will draw two things here. One thing is Gantt chart and second thing is queue. So here at a below space we are going to draw the queue, and for a few step upper level here we will draw the Gantt chart. Done. So let's start. We will always we are going to draw the Gantt chart from time unit 0. So first we will look at a arrival time 0 if any process is arrived or not. So here process P1 was arrived at arrival time 0. So definitely we will put process P1 into the queue, and definitely P1 will got the CPU for execution of first time. Now no need to compare or check the arrival time of other processes, because at a time unit 0 no process was arrived other than P1, only P1 was arrived, as well as we will follow the time quantum. So we will look how many time process P1 will get the CPU. So it is depend on burst time of process P1. Here burst time of process P1 is 8 time unit, but right now we have a time quantum of 4 time unit. So we will allocate CPU only for the amount of 4 time unit. Get it? So here we are allocating CPU for the 4 time unit. So here P1 have to left the CPU for the other processes, because after completion of time quantum all number of processes will left the CPU for the other processes which processes are waiting for the CPU inside the queue. Get it? We will see here if any processes are waiting into the queue or not. Right now we reach at time unit 4. So we will check up to the time unit 4 any other processes were arrived or not. Yes, process P2 was arrived at time unit 2 and process P3 was arrived at time unit 4. So we will put this both the processes into the queue, P2 and P3. P2 arrived at time minute 4 and P3 arrived at time minute 4. So we will allocate CPU to the process P2 first, but before allocating CPU to the P2, we will put P1 into the waiting queue, because P1 still requires CPU for the 4 number of more time units, because out of 8 time unit burst time, P1 uses the CPU only for the 4 time units. So next P1 will goes into the waiting for the CPU. But right now we are going to allocate CPU to the process P2. Queue is working on first come first serve basis. Get it? So whatever the process arrived inside the queue first, those number of processes will served first. Right now P2 arrived first into the queue, so we will allocate CPU to the process P2. P2 was arrived at time unit 2. So right now P2 is getting the CPU and P2 will execute for the 4 time units. Actual P2's requirement is 10 time unit for the CPU, but we are able to allocate only 4 time units up to the time unit 8. Then after the time unit 8, P2 will left the CPU and P2 will goes into the waiting. But before putting P2 into the waiting, we will check up to the time unit 8 any other processes arrived or not. Yes, up to the time unit 8 process P4 and P5 were actually arrived at time unit 6 and time unit 8. Done. So we will put P4 and P5 into the waiting inside the queue. So P4 and P5 we are putting into the waiting queue, and then after we will put process P2 after the P5, because actually P5 was arrived at time unit 8, and after arriving process P5, P2 completed its execution for a time quantum of 4 time units. So first we will put P4 and P5 into the queue, and then after we will put P2 inside the waiting queue. Next we are putting P2 inside the waiting queue, and now we will allocate CPU to the process P3, because inside the queue process P3 was arrived first, so P3 will get the CPU first. Arrival time of process P3 was 4 time unit, so P3 will execute and P3 get the CPU, but actual requirement of P3 is 4 time unit. Burst time of P3 is 4 time units, so P3 will use the CPU at time quantum 4 time unit, so 8 plus 4, P3 will use the CPU up to 12 time unit, and now there is no more requirement of process P3. So here P3 is completing its execution, so 12 time unit will become the completion time for process P3, and due to the complete execution of P3, we will not going to put P3 inside the waiting queue, because now P3 is no more require CPU. Done. So up to the time unit 12 we will check any other process arrived. Yes, process P6 was arrived at time unit 12. So again we will put process P6 into the waiting queue. Now whatever the process is arrived first inside the queue, that process will get the CPU. So P1 was arrived first inside the queue, so P1 will get the CPU again. So next process P1 will execute, and P1 will execute for the time quantum of 4 time unit. Actually P1 was execute first from 0 to 4 time unit, and again its requirement, total requirement of P1 was 8 time units. So again P1 will execute for the 4 time units, 12 plus 4 it will be 16. So P1 got the CPU 2 times 0 to 4 and 12 to 16. It means P1 got the CPU for 8 time units, and actual requirement of P1 was 8 time units. So here P1 is completing its execution, there is no more requirement from the process P1. So 16 time unit will become the completion time for process P1. Now next process inside the queue, that is process P4. P4 arrived at time unit 6, and now P4 will get the CPU. Actual requirement of process P4 is 2 time unit. Actually we have a time quantum of 4 time unit. We can allocate CPU to the process P4 for the 4 time unit, but there is no more requirement of P4. P4 requiring the CPU only for the 2 time unit. That's why P4 will use the CPU for only 2 time units. 16 plus 2 is equal to 18. So 18 become the completion time for process P4, and there is no need to put P4 inside the waiting queue, because P4 completely executed. Next process P5 will get the CPU. Arrival time for process P5 was 8 time minute. Now P5 is getting the CPU and requirement of P5 is 12 time minute. But here we are able to allocate CPU for the 4 time minutes only. 18 plus 4 22. At a time minute 22 P5 will left the CPU and P5 will go inside the waiting queue. Next process P2 will get the CPU. Actually P2 got the CPU from time minute 4 to time minute 8 for the 4 time minutes, and requirement of P2 is 10 time minutes. Again we are able to allocate CPU for the 4 time minutes as per our time quantum. So we will allocate 22 plus 4 26 time minute. Up to the 26 time minute P2 will execute, and then after P2 will left the CPU and P2 will go for the waiting queue, because again P2 require CPU for the 2 time minutes. Now P6 will get the CPU because P6 was arrived at time minute 12. P6 is getting CPU for the first time and P6 requirement is 6 time minute. So right now we are able to allocate CPU to the process P6 only for the 4 time minutes. So 26 plus 4 it will become 30. At a time minute 30 P6 will left the CPU and go for the waiting. Now P5 will get the CPU and P5 will execute. Before this moment P5 got the CPU from 18 to 22 time minutes for the 4 time minutes, and actual requirement of P5 was 12 time minutes. So here again we will allocate CPU for the 4 time minutes. 30 plus 4 34. So P5 got the CPU 2 times 18 to 22 and 30 to 34. So completion of work from the process P5 is 8 time minute. Actual requirement is 12. So again P5 requires CPU for the 4 time minutes more. So P5 will go for the waiting queue, and again P2 will go, get the CPU. Now process P2 will start its execution. Before this moment P2 got the CPU 2 times 4 to 8 and 22 to 26. It means P2 uses the CPU for the 8 time minute and requirement of P2 is 10 time minutes. So again P2 is requiring CPU for the 2 time minutes. So 30 plus 2 36. At a time minute 36 P2 will complete its execution and 36 time minute will become the completion time for process P2. Now only 2 processes are remain, that is process P6 and P5. Due to the first come first serve as per the criteria of queue, P6 will execute first and P6 get the CPU. Before this moment P6 got the CPU here from 26 to 30 for the 4 time minutes, and actual requirement of P6 was 6. So again P6 is requiring CPU for the 2 time minutes. 36 plus 2 it will be 38, and 38 time minute will become the completion time for process P6. Now only process P5 remain. So P5 will get the CPU. Before this moment P5 got the CPU 2 times 18 to 22 and 30 to 34. 4 plus 4 total 8 time unit P5 uses the CPU, and right now total requirement of P5 is 12 time minutes. So again P5 will use the CPU for the 4 time minute. 38 plus 4 and 42. Here P5 completes its execution because P5 uses the CPU into the time slots of 4 time minutes 3 times 18 to 22, 30 to 34 and 38 to 42. So here at a time minute 42 P5 is completing its execution. So 42 time minute will become the completion time for process P5. Now we have a completion time for all 6 processes. So we can find we are able to find out the turnaround time. So as per the earlier video we have discussed equation of turnaround time is completion time minus arrival time. So we will find out turnaround time for the process P1. 16 minus 0 it will become 16. Next 36 minus 2 it will be 34. Next 12 minus 4 it will become 8. 18 minus 6 it will become 12. 42 minus 8 it will become 34. 38 minus 12 it will become 26. So these are the values of turnaround time. We got it from the completion time minus arrival time. So total turnaround time means whatever the time processes are spending, as well as while processes is using the CPU, as well as processes are pending in waiting into the queue. Now we want to find out only waiting time. So how can we find out the waiting time? Actually processes are waiting here inside the queue and processes are executing here into the Gantt chart. So time of Gantt chart plus time of queue, that is total turnaround time. Processes are spending total time. So if we require the time whatever the processes are spending inside this queue, so definitely we can subtract this time whatever the time processes are using the CPU, we will subtract this time from the total time, total turnaround time. So definitely we will got the time whatever the processes are waiting inside the queue. So for finding the waiting time, there is a equation turnaround time minus burst time. So for the process P1, 16 minus 8, it will become 8, 34 minus 10, it will become 24, 8 minus 4, it will become 4, 12 minus 2, it will become 10, 34 minus 12, it will become 22, and 26 minus 6, it will become 20. So these are the values of waiting time. Here we got the values of turnaround time as well as waiting time for all 6 processes. Now we require the average turnaround time and average waiting time. So for the finding average turnaround time, we will make the summation of all these values 16 plus 34 plus 8 plus 12 plus 34 plus 26. So we will get 130, and we will divide total 130 divided by number of processes P1, P2, P3, P4, P5 and P6. Here there is a print mistake, you have to consider P6. So we will divide it by the 6, 130 divided by 6, so we will get 21.66 time unit, that is total average turnaround time. Next we will find average waiting time. For finding the average waiting time, we will make summation of all this waiting time 8 plus 24 plus 4 plus 10 plus 22 plus 20. So we will get total 88, and we will divide 88 by the total number of processes. There is total 6 number of processes, so we will make 88 divided by 6 and we will get 14.66. Get it? So it is our total average turnaround time and average waiting time. If any time unit is given to you into the data table, it should be like microseconds or milliseconds, so you have to write here into the answers. Now till today we have completed 4 CPU scheduling algorithms, that is FCFS, first come first serve, shortest job first, preemptive priority scheduling, non-preemptive priority scheduling, 2 cases for the priority scheduling, and then after we have discussed round robin algorithm, as well as we have discussed limitation of first come first serve and shortest job first. So hope you understand entire topic of CPU scheduling, and wait for the new upcoming videos. Thanks for watching Devrat Knowledge Villa.